Okay, starting 1.2, graphs of equations. For example 1, we need to determine whether each point lies on the graph of the equation. Okay, so all we have to do is plug in this point, the x and y values, and see if it works out to be true or not. X squared. Okay, so we get negative 16 over 3 equals 8/3 minus 8. So we put the 8 over 1, we need a common denominator. I get negative 16 over 3 equals 8 over 3 minus 24 over 3, which gives us negative 16 over 3 equals negative 16 over 3. All right, if the equality turns out to be true, then that means that this point lies on this graph for this equation. All right, so your answer is yes. All right, going on to the next problem. For part B, we have to plug in these x and y values. So plug them in, and I get 9 equals 1/3 times negative 3 cubed minus 2 times negative 3 squared. So you have 9 equals negative 9 minus 18, which gives you 9 equals negative 27. And that is not true. That is false. So this point does not lie on the graph of this equation. Your answer is no. All right, going on to example 2. All right, for this example, they give us a table, and they give you particular x values. You have to plug those in and figure out what the y values are. Okay, so plug it in, plug it in, plug it in each time and figure out what the y values are. And we get negative 2.5 for the first, negative 1 for y for the second, negative 1/4, 0.5. Okay, so we have, for our coordinates, negative 2, and then negative 2.5, squeeze it in there. Then we have 0, negative 1. Then we have 1, negative 1/4, or negative 0.25. Then we have 4/3, which is also 1 1/3, or 1.3. Then we have 2 and 0.5. Okay, so now we go ahead and we graph all these points. So I have negative 2, and then I'm down 2.5. Right about there. Then I have 0, negative 1. Then I have negative 1/4, or 1, and then negative 1/4. So I'm right here. Then I have 4/3, which is 1 1/3, and 0. So 1 1/3, and then 0. And then I have 2, and then I'm up at 0.5. All right, so there are all my points. Now just graph the line. That's all there is to that. And this method works for graphing any type of equation. If you're ever stuck and you're looking at an equation and you're thinking, I have no idea how to graph this equation by hand, well, just choose a bunch of x values of your choice, figure out what the y values are, and you could get a semi-accurate graph that way. All right, going on to example 3. All right, to find an intercept, very important concept, set the opposite variable equal to 0. Always set it equal to 0. All right, so for this graph, or this equation, I need to find the x-intercept and the y-intercept. Or there could be more than one. Okay, so if I'm going to find the x-intercept, I need to set y equal to 0. All right, so I plug in 0 for y. I get negative of x plus 10, absolute value. Okay, now since I have a negative in front of the absolute value, I need to isolate the absolute value first. So I divide by negative 1. And I get 0 equals the absolute value of x plus 10. All right, so we set x plus 10 equal to the positive case and the negative case, but positive and negative 0 is essentially the same thing. It's just 0. Okay, So we're just going to have x plus 10 equals 0. Subtract 10. And I get x is equal to negative 10. All right, that's my x-intercept. If you list it as a point, it's going to be negative 10, 0. For the y-intercept, we have to set x equal to 0. Once again, the opposite variable equal to 0. So y is equal to the negative of 0 plus 10. We have y is equal to the negative of 10, absolute value of 10. And what is the absolute value of 10? It's just 10. But then you have this negative on the outside, so you attach that to it. So our y-intercept is negative 10, or if you list this as a coordinate, it's going to be 0, negative 10. All right, going on to the next example. All right, for example 4, sketch the graphs of the equations by plotting points until you are familiar with the parent functions. Okay, so like I said before, if you have no idea how to graph the equation that you're looking at, then just choose x values, figure out the y values, and you'll get a semi-accurate graph. All right, so I'm going to choose negative 2, negative 1, 0, 1, and 2. Okay. Now, when I do that, I'll plug in negative 2 for x, and you simplify the expression, or the equation, and we get square root of 3. We get square root of 2. Then we get 1, we get 0. If you plug in 2, you get the square root of a negative number, and no can do, so can't have that one. All right. Before we start plotting points, it's important to know what these square roots are approximately equal to. This will help you on the SATs as well. Square root of 3 is approximately equal to 1.7. Square root of 2 is approximately equal to 1.4. Okay, let's graph these points. So I have negative 2, and I'm up 1.7. Then negative 1, I'm up at 1.4. At 0, I'm up at 1. At 1, I'm at 0. Okay, so here we go. This is how the graph looks. All right, so it looks like a wave for the square root function. All right, now go to part B. Same process, just choose a bunch of x values. These are the typical ones that I choose. You can choose others, though. All right, plug those x values in, figure out what the y value is. I get negative 1, 0, 1, 0, negative 1. All right, so plotting these points, I have negative 2 down 1, negative 1, 0, 0, 1, 1, 0, and 2, negative 1. All right, and you get this V-shaped graph since we're working with the absolute value. All right, now you have the yellow sheet that shows you all these different functions, and you're going to start to notice a relationship with regards to what happens when you add or subtract something inside of the square root or the absolute value, what happens when you add or subtract something from the outside, what happens when there's a negative in front. Okay, so pay attention to those things. Study that sheet, because once you understand the relationship, that relationship applies to all the different functions. All right, going on to example 5. All right, equation of a circle. What is it? X minus h squared plus y minus k squared equals r squared. Okay, and the center of the circle is hk, and the radius is r. All right, so they ask you to write the standard form of the equation of a circle with the given characteristics. They give you a center, and they give you a solution set. What does that mean exactly? What does this mean? It means a point that's on the circle. So this is a center, that's your h and k. If this is a solution set, it's a point on the circle, then that's your x and y. Okay, so plug these values in. And simplify. Take your time, be careful with your calculations. All right, so we're going to have to square root both sides to get r by itself, and r is equal to 5. Okay, now to state the equation, we have to include the center of the circle and the radius. All right, so it's going to be x minus h, which is 3, squared, plus y minus k, which is negative 2, equals r squared. So I get x minus 3 squared plus y plus 2 squared, and that equals 25. All right, and that's all there is left to do with this type of problem. Don't start foiling and all that business. You're done at this point. You wrote the equation of a circle. Okay, moving on to the next example. All right, find the center and radius of the circle and sketch its graph. All right, here we just have x squared by itself. So what do we do in this case? Well, what are you subtracting from x if it's just by itself? You're subtracting 0. And how do you rewrite 1 as a square? Well, that's just 1 squared. All right, so here's my h, here's my k. All right, now a rule to remember is that whatever you have here, you just take the opposite sign of that. Same here, opposite sign of that. So if you had x plus 2 squared, for example, then h would be equal to negative 2. That's one way to prevent yourself from getting mixed up. Just take the opposite sign, and that's your h, and that's your k. So h in this case, for the center, is 0, and k is 1. All right, my r is 1. Graphing the equation, I start at the center, 0, 1, and then my radius is 1, so I go up 1, down 1, left 1, right 1, and then graph your circle. All right, that's all there is to it. All right, now begin your assignment at the bottom of the web page. Make sure to answer, or ask questions if you have any.